Hey guys, volume of prisms today. By definition, a polyhedron is a three-dimensional figure whose surfaces are polygons. Remember, a polygon has to be flat, two-dimensional, has to be made up of only segments, there can't be any curves, and these segments will always meet end to end. So a polyhedron won't have curves since it's made up of polygons. A polyhedron that has exactly two congruent parallel bases we call a prism. There's different parts of the prism. So we've got two bases, and then the other sides are called the lateral faces. Lateral faces of a prism are the sides of the prism that are not bases. The blank of a prism are the two congruent parallel faces that are connected by the lateral faces. The bases of a prism are going to be congruent and parallel. And then the blank of the prism is the perpendicular segment joining the two bases, the height. Remember back in polygons last chapter, the height and the base always had to be perpendicular to each other. Same thing with solids. The height is always going to be perpendicular to the two bases, so don't forget that. Here we're going to practice naming the prism, identifying the bases, the lateral faces, and the height of each prism. So what I like to do is shade in or color my bases. I'm going to say here that the top and bottom are the bases. They're congruent, they're parallel to each other. So to name this prism, it's the shape of the base, so rectangle. So we're going to call this a rectangular, sorry about the poor handwriting, prism. The height of the prism has to connect the bases, so it could be any of these four vertical segments that are connecting the base, but that is the height. The other four rectangles that are going around that prism, those would be considered the lateral faces. I'm not going to color them in, it's going to get crazy. To the right here, my two congruent parallel bases are these triangles. So when we go to name this solid, it's called a triangular prism. Since there's two congruent bases, that makes it a prism. The height, remember, has to connect these two bases, so it could be any of these three vertical segments. That is your height. The three rectangles that are going around, that's considered the lateral face. Now, both of these two have the heights going vertically. Height doesn't always have to be vertical, you guys. The height has to connect the two bases. You got to remember that. The height's going to join the two bases. Pause the video here and name the bottom two prisms on your own. Number 3 here, I'm shading in my bases in green. There are 1, 2, 3, 4, 5 sides to those bases. So we're going to call this a pentagonal prism. The height of this prism has to connect the two bases. It would be one of those 5 vertical segments that connect the two green pentagons. Lateral faces, there would be 1, 2, 3, 4, 5 rectangles that are going around it. And the last one here, if I shade in my congruent parallel bases in orange, 1, 2, 3, 4, 5, 6, those are both hexagons. So this is called a hexagonal prism. The height has to connect the two bases, so it could be any of those 6 vertical segments that are connecting the bases. There would be 1, 2, 3, 4, 5, 6 lateral faces going around it. Awesome. So remember, volume is the number of cubic whatever that can fit inside of a figure. Number of cubes, it could be a cubic inch, a cubic foot, a cubic yard. Number of cubes that fit inside the solid. We have a formula to use for prisms, and to find the volume of the prism, it's big B times H. Notice the B is capital. big B throughout this entire chapter will always stand for the area of the base. And then H is the height of the prism, and remember the height of the prism has to connect those two bases. So because we just took our test over the area of polygons, we're going to continue to use all those within this chapter to find the volume of solids. Going to the next page here. We're going to find the volume of 4 prisms here. And remember to try and show your work, be neat and legible. We have it set up here so it helps organize it. At the top, though, I would write our formula down to find the volume of prisms. Volume equals big B times H. Remember, big B stands for the area of the base. I'm going to start how I started on the front side when I was naming those and find the base to start. This first one is a rectangular prism, so the shape of the base would be a rectangle. I'm going to use the bottom and the top as my bases. And then the height has to connect those two bases. So in red here, I'm going to highlight my height. My height is 6 centimeters, so over on the right, I'm going to put 6. To find big B, the area of the base, well, I have to be able to find the area of our rectangle. To find the area of a rectangle, it's base times height, or length times width, which in this case is 12 times 8. So the area of our base would be 96. To find the volume then, you guys, well, at the top, volume is big B times H. So now we need to take 96 times 6, and we get 576 centimeters cubed. Volume is cubic, so that means there could be 576 little cubes that were a centimeter by a centimeter that would fit inside of that rectangular prism. Don't forget, maybe you did forget, I'm not going to tell you not forget, but back in the day, previously in your academic career, when you had to find volume of prisms, you would do length times width times height, 12 times 8 times 6. That would also work anytime you have a rectangular prism. To number 2. To name this, we would call this a triangular prism, which means the shape of the base is a triangle. So I'm going to shade in my 2 triangles here. The height of a prism, you guys, has to connect the 2 bases. So the segment that's connecting these 2 triangles is this here going back, front to back. That's the height of the prism. Okay, if you need to turn your paper or something so it looks like it's going up and down, that's fine. But remember, height doesn't always go up and down. Big B stands for the area of the base. This time, the shape of our base is a triangle. To find the area of a triangle, it's 1/2 base times height. So I'm just looking at this blue triangle. I'm actually going to redraw it here so we can just focus over here on the blue triangle. The height is 6, the hypotenuse is 10, and our base would be this bottom segment, which we don't know, so I'm going to call it x. We have to find what x is so that we can find the area of the triangle. So you guys, we're going to have to use our Pythagorean Theorem. X squared plus 6 squared equals 10 squared. 36, 100, subtract 36 over. X squared equals 64. Square root both sides, and x equals 8. So then to find the area of this blue triangle, we're going to take 1/2 8 times 6, which would give us 24. So we're still going to have to use our Pythagorean Theorem. You may have to use special right triangle rules. Work these slowly. Work one part at a time. To find the volume then, we have to take the area of the base, 24, times the height, 11, which gives us a volume of 264 centimeters cubed. Cool. 2 left. Number 3. Erase some of this up here, you guys, so I have more room. It is yet another triangular prism, which means the shape of our base is a triangle. I like to color them in. If you're not printing these or you're unable to and you have to draw them, I would suggest also coloring them in. Remember, the height of the base has to the height of the prism has to connect the two bases. So here the height's going to be 10. We have to find the area of the blue triangle. Now if I redraw it, the bottom is 18, the left side is 18, and the right side, you guys, is 18. It's in the back there. So what we have is an equilateral triangle. You could use 1/2 base times height and draw in your altitude there, if you wanted to. Or if you remember from last chapter, I did teach you this before we left for, well, the year, I suppose. There's a shortcut to find the area of an equilateral triangle. It's side squared square root 3/4. The side length here is 18, so 18 squared square root 3/4. 18 squared is 324. And 324 divided by 4 is 81. So big B is going to equal 81 square root 3. To find the volume then, to find volume, it's big B, the area of the base, times the height of the prism. If we were to find the exact volume, we would say it's 810 square root 3 units cubed. If I asked you to round that to the nearest whole number, then I would put that in the calculator and I get about 1,403 units cubed. So just watch the directions, what it says. If it doesn't say where to round or leave an exact form, then it is your choice, you guys. Cool, cool, cool. Last one, a composite figure. So we had composite figures when we were finding area last chapter. We're also going to have composite figures here when we find volume. Same idea. You're going to find the volume of one part, find the volume of the other part, add them together. Sometimes you have to draw in your own lines, so that's what I'm going to do right now. I'm going to use a different color here. I'll use purple. I'm going to draw in this purple horizontal line. So I have a top prism and a bottom prism. The top prism will go in green here. Top. If I use, I don't know, I'll just use the top of it as the base here. Then the height has to connect the top and bottom, so it'd be this little red segment here. You might have to go back and rewatch this one a couple times here. To find the area of the green rectangle on the top, big B, I'm going to take 2 times 8. This would be 8 here, since it's the same length as this 8 on the bottom. So to find the area of the green rectangle, 2 times 8 equals 16. The height of that prism in here that I made is this red segment, which is 3. So then the volume of the top prism, volume equals big B times height, would be 48. That's just the top prism. Now I have to find the volume of the bottom prism. We'll work in blue here. If I'm going to use the front of this just because my shading's getting crazy, as the base here. This blue rectangle, that's going to be the base of my bottom prism. To find the area of that blue rectangle, I have to multiply the dimensions 6 by 2. 12. The height then has to connect the front to the back of that prism. So my height for the bottom prism becomes 8. The volume then on the bottom would be 12 times 8, which is 96. So to find total volume, you guys, we're going to have to add 96 plus 48, which is 144 centimeters cubed. Again, you might have to go back and rewatch that one. There's different ways to do that. You could add lines differently and use different bases. If you have any questions, please email us. Good luck. Have fun.